All right, what's going on, everybody? It's your boy Hank Hackerson at Hank Hacks Hackers, and today we're going to be going through the Yara module that is a part of the SOC Level 1 pathway in tryhackme, and this is all about the security analyst and working at a security operations center, which is most likely what you're going to get as your first gig in cybersecurity. I know we all want to be pen testers, but one of the most important jobs right now, especially in a lot of different companies and organizations, is the SOC analyst. And so that's the pathway that we're on for this video. And today we're going to be talking about Yara. And this is actually one of the subscriber rooms. So you need to have a subscription for this room. And to get your subscription, it's 12 bucks. If you get the link in the description, you'll get a $5 discount on that. So it'll be 7 bucks. Which is super affordable, and then you can start hacking and you can start learning about hacking and all that good stuff. So make sure you like, subscribe, share, comment, and turn on the notification bell so that you get notified the next time that a video comes out. And we're gonna jump into our room here with Yara. And I think we actually do need to use the attack box at some point as well. So let's see. I already Yeah, I don't think we need to actually use the attack box. I think it just opens up a Linux Ubuntu machine for us, and we can just use that as we go along. So that will be fine. So the introduction is basically this room helps you understand Linux familiarity, such as installing software, commands for general navigation of the system. It isn't designed to test your knowledge for point scoring, so you just need to follow along and experiment with what you've learned here, which is actually really awesome, and I'm really excited about that. I would love to learn that kind of stuff, and I love those types of rooms that kind of help you learn by giving you what to type, especially considering the fact that I have never done anything in Yara before. Maybe I have, I don't know if I have or if I haven't, but I don't think I'm familiar with this language and what needs to be done. So let's read into it and see what it actually is. So this I recognize because that's a Python command for the first example. So it says that Yara, the pattern matching Swiss knife for malware researchers and everyone else. That's what Yara is technically, and that's by Virus Total. So with such a fitting quote, Yara can identify information based on both binary and textual patterns, such as hexadecimal and strings contained within a file. Rules are used to label these patterns. For example, Yara rules are frequently written to determine if a file is malicious or not, based upon the features or patterns it presents. Strings are a fundamental component of programming languages. Applications use strings to store data such as text. So for example, this is a Python command, and the print command prints this string onto the screen. And so anything that's inside a quote in the Python language is considered a string. So we could write a Yara rule to search for hello world in every program on our operating system if we like. Okay, that seems actually very useful. So why does malware use strings? Malware, just like our hello world application, uses strings to store textual data. Here are a few examples of the data that various malware types store within strings. So ransomware stores this data, and this is a Bitcoin wallet for ransom payments. Okay, botnet stores this data, which is the IP address of the command and control server. And so both of these are going to be saved as strings here. And I really want to click on this, but I feel like I shouldn't click on this, just in case it goes somewhere and it asks me to pay for something, which I don't think tryhackme is going to do. So why not? Why don't we just click on it and see what's up? So, okay, so it just takes you to, what is this, blockchain.com, and it gives you the Bitcoin balance in this wallet. No freaking way. So this is something that I guess exists right now that people have used previously, and currently there's 1.92 whatever Bitcoin in it, which is a total of $81,000. This is gnarly. So I didn't know that this place existed. So I guess if we go to blockchain.com and look up any address, we can try to see what the balance of that address is. And I'm super tempted to try to see what is going on. So this address has transacted 248 times on Bitcoin blockchain. It has received a total of 19 Bitcoin, which is basically $840,000, and has sent 17 Bitcoin. The current value is so on and so forth. So this is crazy, yo. I did not realize that something like this existed. I mean, I'm not surprised that it does, but this is insane. So wow, I'm gonna get distracted just to analyze all of these transactions, but this is freaking insane. So that's an actual address. That's an actual address that has been used to collect ransomware. And so what we can do is we can basically set up a Yara script to search for this address inside the computer or inside any script, and it'll kind of give you the hint that, hey, this has been used for ransomware before. And if you see this string inside any file, you can assume that that file is probably a ransomware file and what it's going to do. So that's pretty crazy. Explaining the functionality of malware is vastly out of scope for this room due to the sheer size of the topic, and there is more detail in task 12, which is strings of the malware introductory room. In fact, I am creating a whole learning path for it. If you'd like to get a taster whilst learning the fundamentals, I would recommend my room. Okay. Who made this room? Let's see, who is it? Who created this room? Can we see the author of this room? Let's see. Nope, doesn't show it. What's here? Nope, doesn't show it. Save room. This is pretty gnarly. I love this so much. Oh, I see. So maybe CMnatic is the person who created this room. Okay, let's not get distracted. Okay. So first question right here is, what is the name of the base 16 numbering system that Yara can detect? So let's see, what is it? What's the hint? This is also known as hexadecimal. An example of this is this. I would say hexadecimal, I think. Hexadecimal. Is that the answer? That is the answer, okay. Would the text enter your name be a string in an application? That is yes. Very good. So we have gotten our first two answers for what is Yara. Okay, so now let's deploy the machine. And in browser, no VPN required. That's what it's going to look like. And then the SSH, if you wanted to connect to it via SSH, you would have to be connected to the open VPN or the VPN of tryhackme, so that they'll allow you to do it. And then the IP address is what will show up right here when the machine is finished loading. And then this would be the username that you could use, as well as the password. And of course, you would do SSH port 292 to secure shell your way into this machine. So that's how we would deploy that. So let's talk about Yara Rules while this machine loads. I'm going to exit the split view just so it doesn't mess with me later. So here are some of the rules. So the proprietary language that Yara uses for rules is fairly trivial to pick up, but hard to master. This is because your rule is only as effective as your understanding of the patterns that you want to search for. So the Yara rule is simple. Every Yara command requires two arguments to be valid. Number one is the rule file we create, and number two is the name of the file directory or process ID to use the rule for. So for example, if we wanted to use myrule.yar on some directory, we would use the following command: Yara myrule.yar some directory. Okay, simple enough. Note that .yar is the standard file extension for Yara rules. We'll make one of the most basic rules you can follow below. So that's it. Make the name file called some file, and you can do touch some file, and create a new file and name it myfirstrule.yar, like below, and then open myfirst.yar using a text editor such as Nano, and input the snippet below and save the file. And basically the rule is example rule, and we have these squiggly brackets. Condition is true, and then you just save it. And so nano myfirstrule.yar, and then it'll open up that, and then you would save that in here. And that's basically what we're doing to create our first YAR file. So the name of the rule in the snippet is called the example rule, where we have one condition. In this case, the condition is condition, which is this thing right here. As previously discussed, every rule requires both a name and a condition to be valid. This rule has satisfied those two arguments. Simply, the rule we have made checks to see if the file, directory, or PID, which is process ID, that we specify exists via condition true. If the file does exist, we are given the output of example rule. Let's give it a try and on the file that we just made, which is some file, and see what that is, right? So it will be Yara my first rule.yar and then the sum file. If some file exists, Yara will say example rule because the pattern has been met, as we can see below. So example rule, some file, that would probably be the result, right? If the file does not exist, Yara will output an error such as error scanning some text file could not open file. Okay, so fair enough. So you've made your first rule. Let's actually make the rule because I've never done this before and I'm very, very interested to see this. So we have our thing, and so just to actually get the error message first, so what I'm going to do is I'm going to first make the yar file, and then we're going to create that rule inside it, and then from that, so nano my first rule.yar, we're going to do that, and there's nano, and then we're going to copy this rule basic, and we're going to paste it in here, and the condition is true, and example is going to be example rule, right? And that's what's going to happen. So instead of saying example rule, just to kind of make it a little bit more modified and personalized, we're going to call it file exists. That's what we're going to call it. So that's going to be the actual name of the rule, and then we're going to do Command O to write it out, and then Command X to close our file, and so that should be it. And it seems like we're now back in our terminal, and so that's what it kind of looks like right here, zoomed in. So let's see if I just do clear, would that work? Yeah, okay, great. So now it takes me back to the top of the screen, and there we go. So rule file exists that we just made, and then if I do ls, it'll show me that I have my first rule.yar file right here, which is great. And then from here, we're gonna run the file, right? So we're gonna do Yara my first rule.yar, and then we're gonna do, what is it? Some file, right? That's the name of the file. And you run that, and it says error scanning some file could not open the file. So there you go. So now we have that. So now we're gonna create some file, and so we're gonna do ls to see if it exists. There you go, it does exist. So now we're gonna run the same command, Yara my first rule.yar, and then some file. And now it says file exists, some file. So there you go. That actually worked, right? So easy enough. We were able to create a simple Yara rule or a Yara file that basically searches the system for us to see if that file exists. And so if I actually did this for any of the other files in here, right? So if let's see what that does if we search for tools, for example, right? So if I go Yara my first rule.yar tools, because it's a directory, so maybe that's why it doesn't exist. So if I go to tools and do an ls here, we have Loki, and let's see, cd Loki, is that a file? No, that's a directory as well. And so let's do ls here, and we have a bunch of things. So there's let's see, cd, let's say cd config. Oh, that's also a directory, cd excludes.cfg. Okay, that's not a directory. Okay, so now we have our path for the file that we want to search for. So I'm going to go back to the home right here, which is, oops, not there. We're going to go here, excuse me. And then inside here is going to be my first rule. So I'm going to do Yara my first rule.yar, and then I'm going to go into that, right? So it's going to be that /tools /Loki /config what's the name of the file? Excludes .cfg. File exists. Okay, there you go. That was like a little bit of a advanced search mechanism. So there you go. Now we can see that the file actually exists. So I wonder if I just did this. So now I'm just kind of playing around with this. So if my first rule.yar, if I just do excludes without the full path, let's see if that works. So it does not exist because we didn't give it the full path. So we have to give it the full path. So we have learned some good information here. And now we're going to move forward to the next piece of this, which is expanding on the rule. And now we're getting into some pretty nitty-gritty stuff. So let's see, it says, checking whether or not a file exists isn't all that helpful. After all, we can figure that out ourselves using much better tools for the job, which is true. Things like locate or find already are kind of inherent to a lot of systems. So Yara has a few conditions which I encourage you to read here at your own leisure. However, I'll detail a few below and explain their purpose. So there is keyword, disk for, or description, I guess, meta, strings, conditions, and wait. So meta is the section of the Yara rule reserved for descriptive information by the author of the rule. For example, you can use DSC, short for description, to summarize what your rule checks for. Anything within this section does not influence the rule itself. Similar to commenting code, it is useful to summarize your rule, okay? Strings actually looks for strings, right? So you can use strings to search for specific text or hexadecimals in files or programs. For example, say we wanted to search a directory for all files containing hello world, we would create a rule such as this below. So the rule is hello world checker, and it's going to look for strings, and the variable, in a lot of languages you would put a $sign in front of it to declare that this is a variable, and then the variable is going to equal this string, and it's inside quotations. And so now we have a rule that is checking for strings, and that string is the hello world string. So we define the keyword strings, and we want to search for hello world is stored within the variable hello world, right? And of course we need a condition here to make the rule valid. In this example, to make the string the condition we need, the variable's name in this case is going to be hello world. And so the variable's name is just going to be the condition as they declared right here. So this is the actual rule, and then within the rule we have created a condition that says check for this variable, right? So essentially, if any file has the string hello world, then the rule will match. However, this is literally saying that it will only match if hello world is found, and will not match if hello world underscore or hello world all caps without the exclamation or anything like that is found. So to solve this, the condition any of them allows multiple strings to be searched for like below. So strings, and then you have hello world with the exclamation, and then the first capital letter, then you have all lowercase, then you have all caps, and then now you say condition any of them, meaning any of these variables would be present, so then it would return true. Now any file with the strings of these things will now trigger the rule. So the condition that we've already used have been true, and any of them, much like regular programming, you can use operators such as less than or equal to, greater than or equal to, or not equal to. So when you put an exclamation in front of it, that's not. And so for example, the rule below would do the following. This is the string, and then it says hello world is less than or equal to 10. So, and they put a number here, so a hash right here. So it says it's going to look for the string and then only say the rule matches if there are less than or equal to 10 occurrences of the hello world string. And this is where that number I think is very important, because in the previous examples it was checking for the actual variable itself by using the $sign. So this part is pretty important. And so combining keywords, and so now you can search with and, not, or, right? So to combine multiple conditions, you would say this is the string, and then the condition is hello world and file size is less than 10 kilobytes. Okay, I mean, it's pretty self-explanatory. So the rule will only match if both conditions are true because we said and, right? So obviously if you put or, it'll bring up any files that has a less than 10 kilobyte file size or any file that has that string inside of it, which is kind of, I mean, it's probably going to bring up a lot of results. So the rule will only match if both are true. To illustrate below, the rule we created in this case did not match because although the file has hello world in it, is that it has a file size larger than 10 kilobytes. And so the output has been intentionally left blank because I think we're supposed to maybe find the answer for that. However, the rule matched this time because the hash has both, because the file has both hello world and a file size less than 10 kilobytes. And so my first rule, my text file, and then it actually worked, right? Remember that the text within the red box is the name of our rule, and the text within the green is the matched file. So where is the red box that we see? I guess here, right here. Okay, so here are some rules can be compiled with Yara C to increase the speed of multiple Yara scans. So you have the import module, so import PE, and this looks like a Python file or a Python language because import belongs to Python. But so Yara modules allow you to extend its functionality. The PE module can be used to match specific data from a PE. So PE number of exports, PE sections, PE im splash, PE imports, or imp hash, import hash, imports the kernel, and then so on and so forth. So the list of modules that can be imported within PE is right here. And then the rule name itself, which is the name that we have done right here. So rule demo rule, and then / tag one demo. And so it's, let's see if it talks about the tag here. So the rule name identifies the rule. It is recommended to add a meaningful name. There are different types of rules, global rules, private rules, and then there is the rule tag used to filter Yara's output, okay? And then you have the metadata that is just being applied to this particular rule. So this is, as they mentioned earlier, it's kind of like comments, so it doesn't really mean anything. So it says rules can have a metadata section where you can put additional information about your rule, like who wrote it, the date, the description, so on and so forth. And then you have number 4, which is the strings that we're looking for. So we're looking for these strings. So string 0 is hello, no case wide, string 1 is hello, full word, ASCII, and then there's the hexadecimal of all of these different characters. And then the variable itself, you're looking for the MD5 of these things. So let's read that. The field is used to define the strings that should match your rule. It exists 3 types of strings: text strings, hexadecimal, and regular expressions. So the third one, I'm guessing, is this is the regular expressions version of the rule. And then we have the text string, which is in green right here. So it says no case means case insensitive. Wide means encoded strings with 2 bytes per character. Full word, do we have that? Yeah, we do. Non-alphanumeric, and then XOR, look for XOR description. Do we even have that in there? I don't think we do. And then you have base 64 encoding, and those things are not referenced here. So we only have ASCII, which is, it's not even referenced here. So then you have the hexadecimal. So hex strings can be used to match pieces of code. So wildcards would be any of these things right here. Jump would be 3B, 24B4. Alternatives F4. I don't know what this means, so I'm not even going to pretend like I could explain that to you right now. I know what hexadecimal means, and I know what a wildcard character is. And so in this particular situation, do we even have a wildcard character? We do not have a wildcard character. And do we have any jumps? Yeah, see, so I don't know. That's kind of still a mystery to me. And then we have our condition, right? So we have the meta, we have the strings, and then now we have a condition. And the condition in this particular situation includes, or let's talk about it. So Boolean operators, which is and, or not, greater than, less than, so on and so forth. Arithmetic operators, plus, minus, multiplication, divide, or the remainder, bitwise operators, and the pipe, and then these various, I don't know what you would call those, counting strings, and then strings offset. So the condition itself is saying uint16, which is a full-on condition. So right here, it's actually has it over here. So accessing data at a given position. Okay, got it. So that's what that does, is that it accesses the data, I'm guessing from the position of 0 all the way to this position, and file size less than 2000 kilobytes. Then you are or, so it says this is one rule, or the number of sections equals 1, and any of the strings that we have over here, and no hexadecimals. So pretty complicated rule. This is why they were saying that it's simple to kind of make these things, but as you develop them, it becomes more and more complicated. So it's looking for a set of strings, so any of the strings or hexadecimals, and then the same condition to many strings for all of them being hashtag. Is that even here? It's not in here. Then scan the entry point value at PE entry point, and then match the length, and then search within a range of offsets. So this is this is a great little cheat sheet to understand, but as you kind of go through it, it becomes more and more complex. So I am not going to pretend like I have memorized any of this, or like I know what the hell I'm talking about right now. So we just know that that's basically what we did. And so Frogger has recently created a handy cheat sheet that breaks down and visualizes the element of Yara shown above, and all image credits go to him. It's a great reference point for getting started. So thank you, Frogger. Now, Yara modules. So frameworks such as the Cuckoo Sandbox or Python's PE module allow you to improve the technicality of the Yara rules tenfold. So Cuckoo Sandbox is an automated malware analysis environment. This module allows you to generate Yara rules based upon the behaviors discovered from the sandbox. As this environment executes malware, you can create rules specific such as runtime strings and the like. So it's very important if you're analyzing malware to not open the malware. You want to open it inside some kind of a sandbox environment that if anything does happen, the sandbox catches it and it doesn't affect your system. That's very important. Then you have the Python PE module that allows you to create Yara rules from various sections and elements of the Windows portable executable structure. Okay, explaining this structure is out of the scope and is covered in the malware introductory room. However, this structure is the standard formatting of all executables and DLL files on Windows, including the programming libraries that are used. Examining a PE file's contents is an essential technique in malware analysis. This is because behaviors such as cryptography or worming can be largely identified without reverse engineering or execution of the sample. It's very important, right? So without doing all of the work of reverse engineering or executing the flipping thing, you can figure out whether or not it's a worm or some kind of cryptograph, so on and so forth. So sounds pretty cool. There we go. So now, other tools and Yara. So Yara tools, knowing how to create custom Yara rules is useful, but luckily you don't have to create many rules from scratch to begin using Yara to search for evil. There are plenty of GitHub resources and open source tools along with commercial products that can be utilized to leverage Yara in hunt operations and or incident response engagements. Loki, what, not who, is Loki. So we're not talking about the Marvel character. It's a free open source IOC scanner created and written by Florian Roth. Based on the GitHub page, it's the detection is based on 4 methods: file name, IOC check, Yara rule check, we are here, and hash check, and C2 back connect check. So there are additional checks that Loki can be used for a full rundown, reference the GitHub README. Loki can be used on both Windows and Linux systems and can be downloaded here. Please note that you are not expected to use this tool in this room. Fair enough. So it's a Python file, as we can establish here, and of course from the Python command here, and -h is for help with most things. So when you run that, it's going to give you the usage. So it says loki.py, and then any of these things could be referenced to the program itself so that it can kind of start doing a bunch of things for you. So things like the path, you can specify what path the file is on, the size probably, that's what S stands for, L if it's a log file or creator log file, remote log host, warning level, alert level, all hard drives, all drives, print all, vulnerability check, rootkit. There's a lot of good stuff in here. So Loki, simple IOC scanner, and the optional arguments, of course, are help. And then you have Thor. That's hilarious. So we had Loki, and then now we have Loki's brother, Thor. Thor Lite is Florian's newest multi-platform IOC and Yara scanner. There are pre-compiled versions for Windows, Linux, Mac, and Mac OS. A nice feature with Thor Lite is its scan throttling to limit exhausting CPU resources. For more information or to download the binary, you can start there. You need to subscribe to their mailing list to obtain a copy of the binary. And note that Thor is geared toward corporate customers. Thor Lite is the free version. Understood? Please note that you are not expected to use this tool in this room. And so this is kind of it. And so this does not seem to be a Python file. And this // implies that it's a shell file or some kind of a shell command. And then so when you run H again, it kind of gives you the help menu. And so you have, the scan options, and then you have various other options like all hard drives, max file size to check, and scan mode. So if you want it to be a quick scan, and so on and so forth. Then you have FENRIR, naming convention, still mythical themed. I don't know exactly who that is though. So this is the third tool created by Florian Roth. You guessed it. In the previous two are named above. What? Okay, I don't know what the hell this has to do with it. The updated version was created to address the issue from its predecessors where requirements must be met for them to function. FENRIR is a bash script. It will run on any system capable of running bash. Nowadays, even Windows can run bash. We're not expected to use this. And so there you go. So //fenrir.sh, and there it is. And then simple bash IOC checker, Florian Roth. YAYA, yet another Yara automaton. It was created by the Electronic Frontier Foundation and released in 2020. Based on their website, YAYA is a new open source tool to help researchers manage multiple Yara rule repositories. It starts by importing a set of high quality Yara rules and then lets researchers add their own rules, disable specific rule sets, and run scans of files. Currently, YAYA will only run on Linux systems, and so that's basically it. So you would go YAYA and yet another Yara automaton, and so on and so forth. So in this section, in the next section, we will examine Loki further. So let's actually see if this exists in our little tools file inside this thing. So if I go to cd tools and list that, we have Loki in there and we have YarGen. So YarGen, and what is this? Third-party DBS tools yargen.py. Let's go to tools in here. What do we got? And that's byte mapper. Okay, so I mean, that doesn't seem like there's a bunch of tools in there, but we do have Loki, and we're probably gonna use Loki in the next task, right? As they said. So let's go to the next one. And yeah, we are gonna use it. And there's a lot of questions that we gotta answer. So let's first and foremost clear our screen over here. And let's zoom out. Do I need to zoom out or zoom, scroll up or whatever? Scroll up, excuse me. Okay, so using Loki as a security analyst, you might need to research various threat intelligence reports, blog postings, and gather information on the latest tactics and techniques used in the wild, past, or present. Typically in these readings, IOCs and their hashes, IP addresses, domain names, etc., will be shared so rules can be created to detect these threats in your environment along with Yara rules. On the flip side, you might find yourself in a situation where you've encountered something unknown that your security stack of tools did not detect or cannot detect. Using tools such as Loki, you will need to add your own rules based on your threat intelligence gatherers or finding them from an incident response engagement. as mentioned before, Loki has a set of rules already, and it's located inside our tools, which we already saw. Navigate to the Loki directory and run Python loki.py help to see what options are available. If you're running Loki on your own system, the first command you should run is update to see if you can update the directory, or it will add the signature-based directory, which Loki uses to scan for known evil, which heuristic analysis has to do with the signatures of files. And so you want to update the signature-based directory of Loki so that it can actually do its job and find based on the most recent update of signatures. This is already executed within the attached VM. And so if we go inside Loki, signature base, and list ls, you'll have IOCs, miscellaneous, and Yara. So navigate to the Yara directory. Feel free to inspect the different Yara files used by Loki to get an idea of what these rules will hunt for. To run Loki, you can use the following command, and they're running Loki from within file directory 1. So file 1 directory. So Yara suspicious files file 1, Python, the path to Loki, and then the file itself, I guess. You are the security analyst for a mid-sized law firm, a coworker, discovered suspicious files on a web server within your organization. These files were discovered while performing updates to the corporate website. The files have been copied to your machine for analysis. They are located in suspicious files. And use Loki to answer the question below. So scan file 1. Does Loki detect this file as suspicious, malicious, or benign? Okay, let's do it. So first we need to go to the, let's see, ls suspicious files. There we go, ls, and we have file 1, ls, index3, or index.php. Okay, so now what I need to do is run loki.py, which seems to be, so if I do Python and just copy their command, tools.loki/loki.py, that should be it, because we're going back 2 times, and then we're going to be inside the home, and then we're going to do, okay, that works, that seems to be fine. And then, so now what? Now I just do /p or /p and then dot, I guess. Let's see if that works. Okay, let's see what this all means here. So we have what? A couple of notices that says starting Loki on this version, so on and so forth, registered plugin, noted file name characteristics initialized with 2841 regex patterns, server indicators initialized, malicious MD5 hashes, SHA1, SHA256, fault positive, all that stuff. So this is all info. Then you have notice that program should be run as root to ensure all access rights to process memory and filled file objects, running plugin, scanning. Now here's the information about the file. So that's the file that's in here. Score is 70, type is PHP, size is that. First bytes are this. And then we have MD5 hash, SHA1 and 256 hashes. Created, score is 70, matches web shell, Yara rule, etc., etc. What do we have as the, and so the detected file is suspicious, malicious, or benign. Oh, I see. So I think it did say suspicious, right? Let's go back, zoom in one more time. Yeah, suspicious objects detected. So I think it is suspicious. Suspicious. There we go. Okay, what Yara rule did it match on? So let's try to find the Yara rule, because I did see that here as well. So the Yara rule match was web shell, metas lsoft, metasloft, whatever. Is that the actual rule? Web shell, metas lsoft. Okay, that is it. What does Loki classify this file as? I see. So in the description it says that it's a web shell, and based on the hint it told us to check the description. So it is a web shell. Based on the output, what string within the Yara rule did it match on? So based on the output, what string within the Yara rule did it match on? And so I believe it's this thing. So string 1 right here, whoops, string 1 $buff. So we're gonna do buff. Okay, so str1. Okay, there you go. What is the name and version of this hack tool? So can we find that information now? And our hint says to check the first bytes, and that's what it is right here. So that looks like a name and version. So B374K 2.2. So B374K 2.2. There we go. Inspect the actual Yara file that flagged file 1. Within this rule, how many strings are there to flag this file? So inspect the actual Yara file that flagged file 1. Within this rule, how many strings are there to flag this file? Got it. So that's where it is. So Yara Thor webshells.yar, and then so scan file 2. Okay, and then does Loki detect this as malicious or benign? And then inspect file 2, what is the name and version of this web shell? Okay, so now we can actually exit this. And so we need to go to the home folder and find the Yara rule, which was inside, what was it? It was inside Yara Thor webshells.yar. So ls okay, so Thor webshells.yar, I ran a locate file, which is, or a locate command, excuse me, to try to find this thing, and it seems like I'm way off with my search for it. So I need to go to cd home first, and there you go, cmnatic, and then from here we can go to cd cmnatic /tools /loki /signature base /Yara. No such file or directory. You gotta be kidding. Okay. So cd cmnatic, cmnatic, like that. Very good. /tools /Loki. Let's see if that worked. Okay, it does work. Great. So I think it was the initial / that was incorrect. So from here now we're gonna go to the cd signature base and Yara, and now we should be inside this thing, and now we have all of these flipping web shells. Holy shiza. So now we're going to do nano Thor, and hopefully it'll fill the rest of it for me. Oh, it doesn't, so I gotta find the oh my god, bruh, where's the flipping thing? Thor, I see Thor hack tools and Thor web shells. So Thor web shells.yar nano. Open this mofo up. Okay. So what's the question? Inspect the actual Yara file that flagged file 1. Within this rule, how many strings are there to flag this file? And so within this rule, how many strings are there to flag this file? So 4, 1, 2, 3, 4. 4 strings. Or maybe more. Seems like there's more. So this is the full scanner. So okay, there's 4 strings here, and then there's 4 strings here. So it's either 4 or 8. So I'm gonna try 8 first, and it's not the answer, so 4. That is also not the answer. What? What are you talking about? How many strings are there to flag this file? Okay, so I had to scroll down for a minute until I found this freaking rule right here called metaslough, whatever the hell this is called. And within this, there's only 1 string. Yo, this is a large file, you guys. So that 1 has to be the answer. Okay, there you go. That was freaking insane. Okay, let me see if I can kind of, oh, you can't see it because I'm going to just hold up and then I'll do like a time lapse from here just so you can see how far I came down to find this. Okay, we're going to do a quick little We're gonna zoom in here, and then I'm gonna do a quick little time lapse type of a thing, just so you can see how freaking long this thing was. Okay, here we go. And there you go. And now we're at the top of the file. That took a long ass time. Just, just to kind of be honest about this. That was insane how long that shit took. Okay, but thankfully, I was able to find the actual answer, and I did it more so because I really wanted to see what the hell was going on here, because that was insane. There was a lot of code, and I bet there was even more code below that, meaning there were more rules. There were just so many rules inside of that. And I mean, thanks to, what's his name? Florian is the guy who wrote this freaking this code or this rule. What's his name? What's his name? Whoever made Thor as well as Loki. It's that guy. What's his name? How am I missing his name? Oh, Florian. It's definitely Florian. Okay, so that dude is freaking badass. Okay, whoever he is, wherever he is, he did all of that work so that we didn't have to do it, and that was one hell of a freaking yikes. That was an experience right there. Let me tell you, buddy. All right, so now we're going to do what? We're gonna scan file 2, and then we're gonna inspect file 2. What is the name and version of this web shell? Okay, so here we go. First, let me plug in this thing so that my computer doesn't die mid-recording. All right, we got that. So now we got to go inside the suspicious files directory and find file 2. So cd suspicious files ls file 2, and we're going to run it with python //tools/Loki /Loki.py p and then dot, and it's going to be file. Oh no, I need to go inside file 2 first. So cd file 2, excuse me. There we go. Now we can run python //tools.Loki.py, and then we can do -p dot, and here we go. Okay, cool. So it ran it over here. It seems that the system seems to be clean, as it says. There's no warning messages or anything like this. So seems to be fine. It doesn't seem like there's an issue here. So which means we could actually probably go inside that file and see what is up, if there's anything in here. So the suspicious, malicious, or benign, it says benign. Or it doesn't say benign, but it doesn't say that it's suspicious or malicious in any way. So that being said, now what I can do is I can actually inspect file 2 and what is the name and version of the web shell. So read the comments in the file. Basically, what we can do is just go here, do ls, what's the name of the freaking file? It's index.php. I'm guessing that's the thing. So we're going to do nano index.php. It's going to open it, and let's read the comments. And the comment says this is the shell. So it is B374K 3.2.3. So B374K, whoops, 3.2.3. Let's see, that's the answer. The remote server is not currently reachable. Please reconnect. Okay, let's try to reconnect. Okay, cool. So we got the exercise done. The research of that took a really long time, just going through that freaking Yara file, the Thor file. But here we go. Let's try to see what we can do here as far as creating rules. So from the previous section, we realized that we have a file that Loki did not flag on. At this point, we are unable to run Loki on the web servers because if file 2 exists in any of the web servers, it will go undetected. We need to create a Yara rule to detect this specific web shell in our environment. Typically, this is what is done in the case of an incident, which is an event that affects and impacts the organization in a negative way. We can manually open the file and attempt to sift through the lines upon the code to find possible strings that can be used in our newly created Yara rule. Let's check how many lines in particular the file has. You can run the following commands: strings, file name, and then wc -l, and it's going to give you this. So I mean, they already did it, but I guess I can run it too. If you try to go through each string line by line, you should quickly realize that this is going to be daunting. That's what it was when I was running through the rule file. So this is the catting the output of the freaking thing, which is, yeah, a bunch of stuff. So luckily we can use YarGen. Yes, another tool created by Florian Roth. This guy is a badass, bro. Whoever this guy is. I'm going to try to see if I can find him on social media. To aid us with this task, what is YarGen? It is a generator for Yara rules. From the README, the main principle is the creation of Yara rules from strings found in malware files while removing all strings that also appear in goodware files. Therefore, YarGen includes a big goodware strings and opcode database as zip archives that have to be extracted before the first use. Navigate to the YarGen directory, which is within tools. If you're running YarGen on your own system, you need to update it by running update. This will update the good opcodes and good strings DBs databases from the online repository. This update will take a few minutes. Once it has been successfully updated, you'll see the following message at the end of your output, which says that, you know, such and such and such. And then to use it to generate a Yara rule for file 2, you can run the following command. And we need to be inside. Oh, it doesn't seem to be that we need to be inside anything. We can just run it from Python yargen.py. We probably have to be inside the YarGen directory, I would say that. And home, semantic suspicious file, file 2, that's where the file is. And exclude good and output it to file 2 yar. And brief explanation of the parameters. M is the path to the file that you want to generate rules for. Exclude good forces to exclude all goodware strings. These are strings found in legitimate software and can increase false positives. O is the location and name you want to output the Yara rule. So got it. So got you. That makes sense. If all is well, you should see the following output, which is generated one simple rule, all rules written to this, and then YarGen rule has finished. Generally, you would examine the Yara rule and remove any strings that you feel might generate false positives. For this exercise, we'll leave the generated Yara rule as is and test to see if Yara will flag file number 2 or not. Another tool created to assist you with this is called Yara Analyzer. You guessed it, by Florian Roth. That guy's a badass. We will not examine that tool in this room, but you should read up on it, especially if you decide to start creating your own Yara rules. And this is all the stuff by YarGen. And so from within the root of the suspicious file directory, what command would you run to test Yara and your Yara rule against file 2? Okay. Within the root of the suspicious file directory, what command would you run? Okay, which would be Yara, the name of the file, and then the thing, and then did Yara rule flag file 2? Probably gonna say yay to that, and then copy the Yara rule you created in the Loki signatures directory, and then test the Yara rule with Loki. Does it flag file 2? What is the name of the variable for the string that it matched on? And then inspect the Yara rule, how many strings were generated, and one of the conditions to match how many strings were generated. One of the conditions to match the Yara rule specifies the file size. The file has to be less than what amount? Okay, so let's start from the top and actually let's create our new rule using YarGen. So first and foremost, we need to be inside the YarGen folder, and I feel like they've already updated it, but let's actually go to tools, YarGen ls, and then do Python 3 yargen.py update. Okay, I think that's done, or at least it seems to be done because that's what it said the update command was going to be. So now what we can do is we can actually run the file and try to create our new rule based on the location of the file 2, or the file that was not detected as such. So I'm going to go back to the home directory, and from here I just want to double check and make sure that within home, so let's print the current working directory, which is home cmnatic. Great. So within here we have suspicious files, and within that we have file 2, so that's all good, and then the PHP file is in there. So we can go back to home, and from here we're going to run the command, which is python 3 yargen.py, which is what we have. I feel like it needs to be inside the actual, no, yeah, I do need to be inside tools, and I do need to be inside YarGen, because that's where the Python file is. Okay, so great. So now we can do python 3 yargen.py, and you're going to look for the file that is in cmnatic suspicious files, and file 2 is the directory, and you're going to exclude, right, exclude good, and you're going to output the rule into home cmnatic suspicious files file 2 .yar, and there it goes. So while that runs, we're gonna make sure that we understand the rest of the instructions. I mean, so we have the new YAR file. It's going to be inside the folder for YAR2, or for the file 2, excuse me. And then so what we can do after that's done is we can go within the root of the suspicious files, run the command, which is yara yar2.yar, or file2.yar, excuse me, and then the directory of the actual file that we're going to be scanning. So let's see, all rules written to that. Yar finished successfully. So great. So now we're here. So now we're going to go back to home, and then we're going to go to cd suspicious files, and where is it? File2.yar. So it's going to be Yara file2.yar, and it's going to be, what are we doing? File2 / what's the name of the thing? I think it was index like that .php, right? That's it. There you go. Let's see if that runs. Cmnatic suspicious files, home cmnatic suspicious files, file2 index file. So that means that is in fact an actual suspicious file, because it didn't say that it didn't find anything, right? So let me, Yara file2.yar file2 / indexphp. That should be the run. Okay, great. Did Yara rule flag file 2? I'm going to say yes. Yeah. Now copy the Yara rule you created into the Loki signatures binary. Okay, so that's what I see. Actually, so it's not, I don't need to do any of that. Actually, I can just go into the signature base, which was right over here. So that's where it would be. So actually I can get rid of that, and I can go to cd back to home, and then there should be in tools, there would be Loki. So I would do cd Loki, and there's a file called signature. There should be signature base. Okay, great. So if I go to signature base, that would be the full thing, and then we have IOCs, miscellaneous, and Yara. And I'm guessing it's going to be inside the Yara. Yeah, and this is where all of the signatures were, including that one that was called Thor. Yeah, Thor web shells. Okay, great. So this is actually the specific directory for that. So we're going to go back to home, so we have that directory listed, and now I need to go ahead and copy the file from the directory that is in, which is this directory that we did. So we want to go ahead and copy this file into the signature directory for Yara. And we're going to use the command cp for copy. And we're going to do home cmnatic suspicious files / file2.yar. And then we're going to put it inside home cmnatic tools Loki signature base Yara. Okay, that seems like it was fine. So now let's see if I can actually find it inside that thing. So if I could just basically do ls, and then I'm going to do home cmnatic tools Loki signature base Yara, and it will just list everything that's already in there, and see if we can find our little rule in here called file2. So it would be, look at all these damn rules. There you go, file2.yar, baby. We got it. Okay, so there it is. So now it's inside the signature base. So now that I've done that, test the Yara rule with Loki. Does it flag file2? So what was the command to actually do it? So I need to go inside where the, let me go back to what we did using Loki to do it. So we were inside the directory for the actual malware, and then we ran it as such. So first I got to go into the directory, suspicious files file2. That's where we are, and we're going to do ls, and there's the file. And so now we're going to run python tools loki loki.py p dot. And so now we're going to run this against the actual new thing with the new rule that we have, and it should show it as a bad thing. So let's see if it actually does. Well, look at that. It actually did give us some warnings and all of that stuff. Nice. So all this actually works. Okay, great. So did the Yara rule with Loki flag the file? Yes, it did. What is the name of the variable for the string that it matched on? So let's see, look at $x1. So is it over here already? I really don't want to go through the freaking file. So let's see. Okay, so it seems like it is not in the output right here, and I have to actually go analyze the freaking file, which is a pain in the ass, but we're gonna do it. Where is our file? It's gonna be in here, file2. So nano file2.yar, and I bet it's one giant thing. Okay, look! Oh my God, look! It seems to be simple enough, and so the hint tells me to look at $x1, which is the very first one right here. Great. And so what's the name of the variable for the string? Is it Zepto? The name of the variable for the string, I'm going to say Zepto. I'm just going to say Zepto. Let's see if that works. That did work. Oh, thank God. I did not want to run through this entire thing. Okay, so what's the inspector rule? How many strings were generated? So we got 1, 2, 3, 7, 8, 9, 10, 11, we got 20. 20 is the answer. Give me 20. 20 is the answer. Great. Are the conditions to match the Yara rule specifies the file size. The file has to be less than what amount? So these are the strings, and then one of them is supposed to say file size. So check, let's see, buff check. Oh, boom, right here. It actually says file size needs to be less than 700 kilobytes. So 700 kilobytes. Press enter. Tell me that's correct. Yes, it is. I am so excited that this did not take as long as the last one, because that was a long ass research phase. Okay, so great. Nice. We're done with this one, and we can move on. We can move on to the last piece right here, which is Valhalla. There's a lot of Greek mythology and not just Greek mythology, but Marvel references. And it's created by none other than Florian Roth. I mean, this guy is clearly, he's a fan of Marvel and Valhalla and all this different kind of stuff, Greek myths and all that. So, online Yara feed created and hosted by Netrock System, Florian Roth. By now, you should be aware of the ridiculous amount of time and energy Florian has dedicated to creating these tools for the community. Maybe we should have just called this the Florian Roth Room. LOL. Hilarious. Yeah, we probably should have. I mean, this guy is a genius. Whoever the hell he is, he's a freaking badass. Per the website, Valhalla boosts your detection capabilities with the power of thousands of handcrafted, high-quality Yara rules. Okay? And so you can query it, API key, JSON or demo, search, etc. From the image above, we should denote that we can conduct searches based on a keyword, a tag, an attack technique, and this references MITRE, SHA-256 hash, or the rule name itself. So for more information on attack, please visit the MITRE room, which we've done a video on, so go watch that video. Taking a look at the data provided to us, let's examine the rule in the screenshot below. So newest Yara Rules, such and such and such is the name of the name, and it says detect suspicious encoded who am I string that is a program to evaluate the current username and often used in malicious or benign recon scripts. We are provided by the name, a brief description, a reference link for more information, along with the rule date. Feel free to look at some rules to become familiar with the usefulness of Valhalla. The best way to learn the product is by just jumping in. Picking up from our scenario, at this point, you know that the two files are related. Even though Loki classified the files as suspicious, you know in your gut that they are malicious. Hence the reason you created a Yara rule using YarGen to detect it on other web servers. But let's further pretend that you are not code savvy. FYI, not all security professionals know how to code or script, or even to read it. You need to conduct further research regarding these files to receive approval to eradicate the files from the network. Time to use Valhalla for some threat intelligence gathering. So enter the SHA-256 hash of file 1 into Valhalla. Is this file attributed to an APT group, yes or no? So from our last exercise, we found out that we can simply find the SHA-256, and hopefully it'll be in Linux as well. So we want which one? For file 1. So we're going to go into file 1 and we're going to run ls, and that's the name of the file. So we're going to do SHA-256 sum and then index with a 3 PHP and give me the sum. There's the sum. Yeah, buddy. So I'm going to try to highlight this and I'm going to see if I can copy it. Okay. That's not what I wanted to do. So is it Control C? Ooh, how do I copy this? Command C? No, that's definitely not it. Okay, so hopefully that copied. Every time I right click it, it does copy paste. So I'm guessing it copied. So let's see if we can go to Valhalla. And that's not what I want to do. So what is their domain name? Valhalla. Valhalla detection. Let's try to see if we can find that. Nextron Systems Valhalla. There we go. And we're going to go in here. I love you, but I do not want you to have my information. So we're just going to save custom choices here. And so what do I need? Get started. Is that where I need to go? Okay, here we go. Let's see if this actually... Oh, it did. So search. Okay, great. So we actually have some things that showed up under this. So what's the answer that we're looking for here? Is this file attributed to an APT group? So reference such and such, description, detect shellstorm, shells, hack tool, web shell found in disclosed attack, APT, Chinese group, yes. So yes, that would be the answer, is yay. Do the same for file 2. What is the name of the first Yara rule to detect file 2? So we're going to now try to delete this whole thing, and we're going to go back to file 2. and cd file 2. And what was the name of the file again? Index. Okay, so SHA 256 sum index with a 1 PHP, and there's that. And now I'm gonna do a highlight real quick, and I'm gonna copy that. And so now I'm gonna go back over here, and we're going to paste that, get rid of the space at the end. Let's search that. Okay, so rule name is this, and that should be the answer to this question. What? What is the name of the first Yara rule to detect file 2? What do you mean, bro? That's literally it. The name of the first Yara rule is this, web shell repo convert. What's going on? What am I doing? Why is that wrong? Okay, so I guess ever since the creation of this room, there were 2 new rules that were applied to this. And so I tried this one as the answer, which is technically the 3rd rule. Or, I mean, it does say rule 1, so maybe that's what it is. So that's the actual answer to this. And so we got that. So now examine the information for file 2 from virus total. The Yara signature match is from what scanner? So let's go to virus total. We're going to take this again with us just in case, because I did not. I'm going to go to here. This is our path. So virus total. And we're going to go here. We're going to search for it by the hash. And so what is the question again? The Yara signature is matched from what scanner? The Yara signature match is from what scanner? Okay, so we got it in the community. It says the signature match is from the Thor APT scanner. So let's see if this is our correct answer here. That is indeed the correct answer. Okay, so enter the SHA-256 hash of file 2 into virus total. Did every AV detect this as malicious? So let's go back here and let's go to our detection tab and let's see if every one of them, no. Every one of them did not detect it. So that's very important to know. And besides .php, what other extension is recorded for this file? So let's see. We have PHP. We have .sys, .txt. Those are the various names. Any other relations that we can find here? Okay, so I'm going to say based on the front page, or details, excuse me, based on the details page, we have a few different names for it right here, which is, most of them are PHP, and then you have a .sys right here, and a .txt. So let's see which one of those might be the answer. I'm going to do sys first. That is not the answer. TXT. That is not the answer. Okay. So let's see what the hint says. Look under the details tab in virus total to find out the extensions for the submission. Dude, I literally did. So under the details tab, which is where we are, is there more? Oh, there is more, I see. So .exe probably. That's probably what it is. I mean, there was a bunch of different ones. So maybe exe is the answer. That is the answer. Okay. What JavaScript library is used by file 2? Let's see if it tells us that in the details here. Okay, well, not accidentally, but what I did was I actually went and Googled from VirusTotal. I ended up Googling this thing, and I went to that JavaScript page for that, or not the JavaScript, the GitHub page for that. But we're gonna do it from the Valhalla page, and it'll bring us here. And then from here, we can try to find the requirements for it, right? And so under requirements, it actually says they need PHP version, yada yada, and then it is using Zepto.js library version 1.1.2. So we're gonna go here, and we're gonna do Zepto as our answer, and that is indeed the answer. And so is this Yara rule in the default Yara file Loki uses to detect these types of hack tools? Is this Yara rule in the default Yara file Loki uses to do the thing? So what is the rule that we're looking for? Oh, I see. The name of it is this thing, web shell B374K rule 1. So let's see if we can go actually and find that. cd ls cd tools ls cd Loki, ls cd signature base, ls cd Yara, ls, and we are looking for, it is called, what is it called? Something, something, something. So what is it? Web shell B374K rule 1. I'm gonna say no, but let's see what the hint says. Examine Thor webshell.yar and search for the rule name. I'm not going back inside of this freaking YAR file. So if this is what the hint says, I'm gonna say yes, it is. It is in there. Oh no, it's not. Golly. So that, I mean, bro, how could I have gone through that whole thing? I could probably grep for it maybe. So let's see. Let's do a little bit of a Googling to see how we can grep for a file, right? So, or through a Linux file. So it's called the okay. There's a little trick that we can use to search while we're in Nano. So if I did Thor webshell.yar and it'll open it up. Web shells, son of a gun. You're so annoying right now. Nano Thor webshells.yar. And so we're inside it. Now from here, I think we could do where is to search for it, and it would be B374. Wait, damn it. B374K, enter. B374K, rule web shell B374K. Okay. Is Yara rule in the default Yara file Loki uses to? I mean, it says that it's there, so why would it say that it's not there? Web shell rule 1. Web shell B374K rule 1. So maybe if I search for, what is it? Web shell 374K rule 1. Maybe if we search for that. So let's try to see if we can find that. So we're going to do Control W for where is or search or whatever. And we're going to do web shell B374K underscore rule 1. Okay, fine. That's not found. But it does say B374K PHP, which is really annoying because it does have that in here. So I guess, but specifically for that, it says, is this Yara rule in the default directory, which is not. Okay, so that was it. That was that. And the conclusion here is that we explored Yara, how to use it and manually create basic rules. We also explored various open source tools created by frickin' homeboy. What was his name? I already forgot his name. But by going through the room scenario, you should understand the need as a blue teamer to know how to create Yara rules effectively if we rely on such tools. Commercial products, even though not perfect, will have a much richer Yara rule set than an open source product. Both commercial and open source will allow you to add Yara rules to expand its capabilities. If it is not clear, the reason why file 2 was not detected is that the Yara rule was not in the Yara file used by Loki to detect the hack tool web shell, even though it's the hack tool has been around for years and has been attributed to at least one nation and state. The Yara rule is present in the commercial variant of Loki, which is Thor. So we had to add it ourselves by using YarGen, and that in itself was very useful. So this was very useful to me. I actually enjoyed this a lot. And I can't wait to expand on my knowledge for this, especially as a blue teamer, right? Because I do love penetration testing, but it's just important to know these. And even as a pen tester, it's important to know which one of these files finds your specific tools that you're trying to use for penetration testing, and if it'll show up as a detection. So all of that stuff I think is really, really important. And I learned a lot. So I hope you learned a lot too. This was one of the longer videos that I've done, and hopefully there was a lot of information that you took away from it. It's your boy Hank Hackerson at Hank Hacks Hackers, and this was one of the paid rooms inside of tryhackme. So this was only available to subscribers. So if you don't have your subscription, you can get it for 12 bucks. If you use the link in the description below, you will get it for $7 because there's a discount through that link. And then you can begin your hacking journey and learn a lot of stuff from tryhackme. Make sure you like, subscribe, share, comment, and of course turn on the notification bell so that you get notified the next time that a video comes out on this channel. All right, peace, love, and chicken grease. I will see you in the next video.